All right, let's get started. Hello, everyone, and welcome to this talk on the Oracle Database Multilingual Engine, or MLE for short. This is an ongoing project in Oracle Labs where we are embedding GraalVM in the Oracle database. So before I get started, a little bit of legalese out of the way. Make sure you take note of that. And with that, so before I get to how we embed GraalVM in the database, it sort of would be useful to spend a little bit of time on why we want to do this. So our overarching goal is to bring modern programming languages like JavaScript and Python into the database as first-class citizens alongside PL SQL. And why we want to do this? We want to do this because it's a polyglot world. Different people prefer different languages. And there's a lot of programmers out there who are comfortable in JavaScript or Python or R, but are not that conversant in PL SQL. And we want their experience in the database to be just as good. Secondly, owing to the popularity of these languages tend to have very large ecosystems of actively developed, very popular modules for a lot of specialized tasks. So for example, JavaScript has NPM, where you can find a lot of modules for doing JSON processing or text manipulation. Python similarly has PyPy, where you can find modules like TensorFlow or scikit-learn for doing data analytics and machine learning. And so once we bring these languages in the Oracle database, you as a developer get access to these modules right in the database instead of like not having to pull the data out. And then there's other advantages, like for example, your applications outside the database obviously tend to be written in these general purpose languages and not PL SQL. And so once you're writing your code inside the database in these languages as well, you get to integrate your workflow in the same, use the same tool chains, use the same version control systems. You get freedom on what piece of functionality you want to keep outside the database, which one you want to push down. You can make the decision much later. So there's a lot of advantages sort of having this choice as a programmer. And so when we started out doing this project, we were looking for how best to do it, like what tools to use. And as I said, we are in Oracle Labs, and so we essentially just looked a few doors down and realized that the perfect project for doing this was right there in Oracle Labs, and that is, of course, GraalVM, which is now a product. So there's a lot of talks about GraalVM in open world. I'm sure you've been to quite a few. If you haven't, I'll show a slide at the end about other talks later today and then also on Wednesday and Thursday. But there's three features of GraalVM, I think, which make this a particularly good fit for what we are trying to do. So the first of these features is that GraalVM is polyglot. So what that means is that you can mix and match languages in your application without having to worry about performance overheads. So you can have JavaScript code and Python code and R code all living in the same application, working together, passing data back and forth. The other nice thing about GraalVM is that you can take all of this polyglot infrastructure and embed that in a JVM-based application, like a Java application, for instance. And that's really useful for us, because then we can implement all of our logic in Java, embed GraalVM, and then give you this functionality. And the last piece, which is also very important, especially for somebody like us who wants to embed all of this infrastructure into a native application like the Oracle database, is that GraalVM is native. So what you can do is you can take your Java application, potentially with all of this polyglot infrastructure, which is actually also implemented in Java, and compile all of that down ahead of time to a native executable. So this can be an ELF binary, this can be a shared library, and once you do that, then you just have binary machine code, and then it becomes much easier to interface with a native application like the Oracle database. And so I think it is worth spending some time on these three features, because not only do these make MLE a great project, I think this is also a great example of how to embed something like GraalVM into a native application. And not just any native application, something as complicated as the Oracle database. So as I said, GraalVM is polyglot and embeddable. So what that means is that you can have code from different languages running in the same application, no overhead to calling out to a different language or to passing data back and forth across languages. Values from one language look like natural values in another language. So it just makes your job easier. Then the other thing is, so this is made possible because languages share a single runtime and are optimized by the same JIT compiler. So what that means is code from all these multiple languages actually gets compiled together. It gets inlined together. You get all the benefits of getting highly optimized code regardless of the language you use. And so from our perspective, this is useful because all of this infrastructure is shared in the back. it is much easier for us to add new languages because all we need to do is add a new front end for a language, and then the back end we get for free. And so from your perspective as a developer, this is great because you can pick whichever library or tool works best for the job at hand without having to worry about, oh, is there a performance implication to using this? And then lastly, as I said, you can take all of this infrastructure and go and embed it into a JVM-based application. So at this point, I think it'll be nice to actually look at some of this in action. This is going to be a little demo of the polyglot functionality of GraalVM. So here I am running Node, the version of Node that ships with GraalVM. This is like any other Node runtime, but there are a few GraalVM specific options. And the one that we are interested in is the polyglot option, which essentially says you have access to all the other GraalVM languages as well. So if I launch a Node polyglot CLI, this is just like any other Node runtime. So I can create JavaScript values and whatnot. But what I can also do is I can do stuff like, so there's this package that GraalVM provides called Polyglot, and that allows you to run code in other languages right from Node. So when I run this, I'm essentially calling out to Python. And if you know range 10, this is simply like creating a Python list of numbers from 0 to 9 and returning it. But the nice thing is, it returned it. I was able to call out, it returned it, and now I have what is essentially a JavaScript variable. And in fact, so this was a Python list, so the corresponding sort of thing would be a JavaScript array. This looks exactly like that. So I can subscript it, I can look at individual elements. This sort of it implements the iterable protocol, so I can do stuff like and you get exactly, so this behaves exactly like a JavaScript array would. And so this is obviously like a toy example, but imagine sort of wanting to do some analytics in say, NumPy. You can call out to Python, do all of this analytics, get back a NumPy array, and what you get back looks exactly like a JavaScript array. You don't have to worry about it. So this makes your job as a programmer a lot easier. It's natural to work with these polyglot objects as they pass back and forth across languages. So the other nice thing I mentioned is that you can take all of this functionality and you can then embed it in a JVM-based application. So here is a little Java class, not doing much. It's just printing out hello world, or hello Java in this case. But then what it is also doing is it is instantiating what in GraalVM we call a polyglot context. So a polyglot context in GraalVM is essentially a repository for all runtime state of languages executing in the context. So I create an instance of that, and then in that context, I can eval like code in any language. In this case, I'm calling out to JavaScript and printing out a string. So then what I can do is I can go and then compile this. It looks like any other Java application. And then I can call out, and you get code running from both Java and JavaScript. Now, one thing you may have noticed is that if you time this application, so there's a little bit of a delay before the JavaScript string prints out, and that's because before we call out to that, you have to go and instantiate the entire JavaScript runtime. That's obviously a non-trivial application. You have to go look for classes, instantiate them, load them. So that takes a little bit of time. And so so just keep that in mind. We'll come back, and I'll tell you how to optimize this further, so you get instantaneous calling out to the languages. So back to our slides. So we looked at how GraalVM is polyglot, how it is embeddable. The last bit that is also very, very important for us is that it is native. So what you can do is you can take all of this. You can take the polyglot infrastructure. You can take your Java code, and then you can compile it ahead of time using GraalVM, the GraalVM JIT compiler. Actually, so this is the same compiler that you use to JIT your Java code at runtime. Here we are using it as an ahead of time compiler. So I'm just taking it, generating a native binary out of it. And so what it is doing, so GraalVM ships with a tool called native image that allows you to do that. It looks at your Java bytecode, and it does static analysis to figure out what classes and what methods would be reachable at runtime. And then it goes ahead and compiles all of that into this binary that you get. And then the other important thing here is that classes are pre-initialized. And what that means is you get much faster startup than you would if you're running this application on a JVM. And I'll show you an example of this in a bit. And then the other advantage is that because you did all this compilation ahead of time, you essentially can skip all the infrastructure for runtime loading and optimization that you would normally have to keep around in JVM. And that means that your memory footprint tends to be a lot lower than running on JVM. So let's go and look at how this looks. So for this bit, actually, I'm going to look at an application domain, which I think this native image functionality is especially well suited for, and that is serverless applications. So I don't know if you guys are familiar with Micronaut, but it is a Java-based framework for writing microservices and serverless applications. The API looks kind of similar to Spring Boot, if you're familiar with that. And so essentially, you just have an application. And in this case, the key portion is I create a controller. I register it via this annotation. And so what this does is it associates this controller with the path conferences. And then I go and associate this method with the path random. And so if I access conferences.random, this class gets run, which in turn goes and looks at this class, which essentially just has a bunch of conferences. And at runtime, when I call this, it just picks one at random, returns it. Conference here is a simple Java object, and then Micronaut does some nice things behind the scenes. For example, it'll call Jackson to convert this to JSON at runtime, so you don't have to sort of do all the boilerplate to do that. And so Micronaut is sort of implemented from the ground up to be sort of aimed at the serverless application domain, which means that you want fast startup, because what's going to happen is when you want to execute this functionality, you're going to start up a Docker container, typically start up your application, and then run your functionality. So fast startup is very important. And so what they do is they essentially sort of try to not resort to reflection whenever possible. They do as many things as possible at build time. And so if I launch this application, you'll see that it starts up pretty quickly. It starts up in like 1.3 seconds, roundabout, not bad. And then you can go and access it. So this is a nice little application you have started up. But the thing is, so 1.3 seconds is already pretty good compared to some of the more traditional JVM-based applications. But the thing is, with native image, you can make this much, much better. So here's all you need to do. So we had built this jar earlier. So this is just like a Java jar. And so as I said, GraalVM ships with this tool called native image. So you can just point native image at the jar. Say I want to compile all of this ahead of time. I did this already because it takes like a few tenths of seconds. So I didn't want to just like take your time. But you run this, it takes like a minute and a half. And what you get at the end of it is a native executable. And this native executable has the same functionality as the Java application that we just wrote. And so if I run this, I get the same service started up, in this case, in like 82 milliseconds in this case now. So it's like about 10 to 15x faster. The exact numbers are not important. You'll see some variation if you did a bunch of runs. But the point is, you get a massive improvement in startup latency. And this also, interestingly, this feature is also something we want in the database, because if you think of OLTP applications, you're going to start a session, and you want to call out a JavaScript. And so we want this to start up very quickly. And so this is a really useful piece of functionality for us. And so indeed, you can use that to also speed up your embedding gap. So you remember we looked at, I said you could make that runtime even faster. So this is exactly what I'm doing here. I'm throwing native image at our little embedding example we looked at. The only difference here from the previous thing where we created native image from the Micronaut app is I'm passing this flag --language.js. And so what this is doing is, in addition to compiling my application itself, which was that single class, it is also including in the native image all the JavaScript interpreter framework as well. So you can throw any JavaScript code at this, and it'll be able to run it. And then it is also compiling in the JIT compiler itself. So the JavaScript code that you run at runtime also gets compiled if code gets hot, etc. And then if you run this is almost instantaneous. Much faster, like, again, orders of magnitude faster. All right. So in fact, we did some measurements on other sort of cloud-native frameworks as well. So it's I showed you a demo with Micronaut, which is in the middle there, that one. But there's Halide and Quarkus as well, which are also very popular framework, which also already integrate well with GraalVM. And we see the same pattern there. Essentially, relative to running on the JVM, you get orders of magnitude faster startup with native image, and you also get a much lower memory footprint. So with this, actually, I've already described sort of most of the infrastructure we need to implement MLE. So this is basically, these are the three pieces of functionality that MLE is using. So this is what our technology stack looks like. We are using most of the goodies in GraalVM. So we are using the language interpreters, all the GraalVM languages up there. We are using the GraalVM JIT compiler to JIT compile this code at runtime, so you get high performance. And then MLE itself is written as an embedding Java application. So that layer is where we are doing stuff like when you pass values from PL SQL to say JavaScript, we are doing data convergence. So a varchar2 appears as JavaScript string and so forth. And again, sort of data convergence on the way back. This is where we implement the SQL driver, which I'll talk about a little bit in a bit. And this is also where we do stuff like execution context management, so that we use different execution contexts for different users. So we separate your runtime state for security and so forth. And then we take all of this and compile that down to a native image. So this essentially, end of the day, becomes a dynamic library. And then there's the dark red layer at the bottom, which is the platform integration layer, which is something I have not talked about so far. But I'll talk about that a little bit towards the end. And then we take all of this, and then this runs on the Oracle database right in the server, so you can run all of this code without taking your data out. So there's sort of two broad ways you can run. By the way, I should mention that in our first version, we are targeting JavaScript. We aim to sort of bring more languages in, but for now, we're targeting JavaScript. And then I'll use the term MLE languages to refer to all the GraalVM languages that we support in MLE. There's sort of two ways you can access MLE language code in the Oracle database. One is via what we call MLE modules and then associated call specification. So you can think of an MLE module as roughly analogous to a PL SQL package. So what you do is you create a schema object via this GDL. You say create a replace MLE module. You say which language you want it in. And here I am sort of inlining the source code. In this case, it's a JavaScript module. And so the source code looks like a common JS module. And so I'm inlining the source code of the module I want to deploy in the DDL itself. But you can also provide this via CLOPS or BLOPS. This just works better for demonstration. And so once I run that DDL, I'll have a module called my module living in the Oracle database. At that point, I can create a call specification, which looks exactly like a PL SQL function from a end user standpoint. That sort of, this is the PL SQL signature, right? It takes in a varchar2, returns a varchar2. You can specify what auth ID you want, just like with PL SQL functions. And then here's the MLE specific bit, where we say this function really points to something in the MLE module, my module, that I deployed here. And more specifically, I'm referring to the function greet in my module. So when you call this function, and when an end user calls this function, what I'm really doing is I'm looking up my module, I'm looking up the function greet within it, and calling it. So in the signature clause, you'll see that I provide a JavaScript signature. So what this is saying is take the varchar2 from PL SQL, convert it to a JavaScript string. So we do have default mappings for this. You can leave this out, in which case the default mapping will be used. But if you want to enforce that a particular JavaScript type be used, you can specify that here. And that's all really you need from an end user perspective. At that point, you can sort of just simply call greet from SQL, and it behaves exactly like a PL SQL application. And so, yeah, I mean, so this is obviously a fairly simple example, but you can have in-out parameters, out parameters, all of that. So the other way to access MLE languages in the Oracle database is via what we call dynamic MLE. So this is a slightly different use case. So in the previous slide, we are deploying something to the database and then creating call specifications. This is sort of more meant to allow you to dynamically execute, like provide snippets as varchar2s or CLOPS. Think of it as like dynamic SQL, and then run it. You can imagine sort of embedding this into like a notebook-style application, for instance. And so what you're doing here is, so this is a PL SQL block where I'm just showing like a high-level overview of the workflow for dynamic MLE. You create a DBMS MLE context handle. So this, if you sort of think back to the embedding demo we looked at a while ago, this context handle is essentially pointing to a polyglot context. So I create one, I get the context back, and then I provide the snippet to be executed as a string or a CLOB in this case. I evaluate it in this context, and then when I no longer need the execution context, I can drop it. So context, as I said, sort of encapsulate all the runtime state. So if you use two different context handles, you can be sure that one, like state in one context, is not going to interfere with state in another context. So it's sort of, you have the freedom as the user to sort of pick out where you want to share application state and where you want to keep them separate. So in call specifications, we were able to pass values back and forth from PL SQL to MLE languages using in and out parameters and return values. So what you do here in dynamic MLE instead is use these methods that we provide called export to MLE, which allows you to pass a PL SQL value to the named dynamic MLE context, and then import from MLE, which allows you to get values back. So in this case here, I'm sort of passing to the context a value which I identify with the name person and which has the value world. And then in the snippet itself, what I can do is then, so in JavaScript, for example, we provide a module, like a built-in module called MLE bindings that allows you to sort of look up these values that you passed in from PL SQL by name, and you get them back as string here. And so then I can do stuff with that, and then I can sort of export it back, and then do the mirror opposite on the other side. Okay, and so this sort of shows you how to pass values back and forth. But obviously, so the point of running this in the database obviously is you want to do processing on data in the database. This is the whole point of it. And so for that purpose, we provide the MLE SQL driver. So the idea is that this is, so for example, if you are running a JavaScript application or Node application outside the database, the way you would access the database would be through Node Oracle DB, which is sort of the standard way to talk to the Oracle database. And so what we provide is a SQL driver that is largely API compliant with Node Oracle DB, with a few exceptions. So for example, obviously you're already running in a database, you're in a session, so that doesn't make any sense to say create a connection. So you already have a connection around, so that's why you just get a default connection object. And then the other important thing to note is that Node is asynchronous, and what we are running in the database is ECMAScript, it's synchronous, and so it doesn't make sense to sort of have an asynchronous API. And so what we provide instead is a synchronous API. By and large, this is essentially the same as calling Node Oracle DB functions with async await. But other than that, this is just like looks and feels exactly like a Node Oracle DB application. So, for here, for example, here I'm calling out to, I'm providing a SQL statement to execute. I can use binds. I can specify what format I want the results back in. Could be an array, could be an object, so exactly as Node Oracle DB again. And then I can essentially, and then I can so at this point I get the values back as JavaScript objects, and I can do with it what I want. Okay, so I think it's time for one more demo. Basically showing this. Essentially, this is. Okay, so this is a. So this is a dynamic MLE snippet. So very similar to what we saw before. I should mention that, okay, so what you're looking at is, so what you're going to work with is a table I've created called customers, which essentially just has a single column called data. So what this is essentially JSON formatted data, which just has customer names, like first names and last names and emails. And the idea is I want to do something with it in JavaScript. And so the way I would do that in MLE is like we looked at earlier. You would use the the MLE Oracle DB package. You would create a connection, and then I would say select data from customers. I get the data back, and then what I can do is, so this is JSON formatted, obviously, so I can just do JSON.parse. I get back a JavaScript object. And then what I'm doing is I'm looking at the email fields of each of these objects, and I'm saying I only want to print out those customers which have an @oracle.com email ID. And then so the dynamic MLE workflow is sort of what we looked at before. You create the context, you evaluate it, you drop the context. And so I can just call this like so, and you get essentially what we said you would get. Yeah. All right. All right. So one thing that I sort of did not talk much about up front, and which is the last sort of piece of the puzzle that we need for something like MLE, is this platform integration. So normally when you create a native image, right, you're still making syscalls to the underlying platform to get system resources, to create processes, to get memory, and so forth. Obviously, that would not be a good idea if you're trying to embed it in the Oracle database. So the nice thing about native image is that it has a fairly narrow and well-defined API via which it requests system resources. And so what this allows us to do is to essentially go in and swap it out so that we can redirect it instead to the database's OS virtualization layer. So what we do essentially is any calls to create processes or threads, or any calls to request or free up memory, those we sort of reroute to the VOS layer in the database. And then any access to file systems or networks we disallow entirely. Because from a security perspective, we don't want somebody running an MLE language being able to access the host file system. So if somebody tries to access this, they'll just get a runtime error in whatever language they're running. And then the nice thing about really calling out to the VOS layer underneath for threading and memory is that you automatically adhere to any limits you might have set in your init.ora file, for instance. If you have any limits on PGA, SGA, all of those will be respected here. You're fully integrated with the resource manager. So if you make an error, like your code is running forever, the resource manager can kill it, just like any other database process. And as I said, there's some nice security properties as well. We can disallow access to any system resources that we do not want people accessing. And that actually was pretty much it. So I think just to recap, what we are doing is we are bringing GraalVM languages to the Oracle database as a first-class citizen. You can use these to create both stored procedures or user-defined functions, or you can use these to run dynamic code snippets. And I think so in addition to sort of MLE itself, what is nice is I think this was a nice proof of concept for us that GraalVM can easily be embedded not just in sort of a JVM-based application, but also in a native application, including with like full integration with the underlying platform. And so we're using native image to make this fast and efficient, and to integrate with resource management. And of course, so what we are using underneath for MLE is the enterprise edition of GraalVM. But if you're interested in GraalVM itself, it comes in two flavors. There's the community edition, which is free, and then there's the enterprise edition, which has some nice additional features. You get higher performance. You get even smaller memory footprints. You get some enhanced security if you're trying to run, for example, C code from Python. For example, you're trying to run NumPy. We are able to run that in a sandbox environment in the enterprise edition. And then, of course, it's a product, so you get full support. And so, as I said, there's a lot of GraalVM-based talks at Open World. So we are right now at this talk. There's a bunch of other talks later today centered around GraalVM as well. So for example, we talked about microservice a little bit. There's one talk here at 5:45. And then there's a bunch of other talks both on Wednesday and Thursday. But yeah. Later today, these talks. Okay. It's already highlighted. You want to add something, Scott? Oh, Eric's talking. Eric's right here. So Eric's talking at 3:15 p.m. That should be an interesting talk, actually. I would like to go to that. All right. So with that, I think that is sort of concludes my talk. And if you have any questions, I'm more than happy to answer them. Yes. So mostly what it is there's some compiler optimizations that are only enabled in the enterprise edition. So you typically get like slightly higher performance. I think the numbers are out there. I don't recall them from off the top of my head, but it's significant. So you get performance benefits. You get even smaller footprint. And then, as I said, if you're interested in running anything, so for example, if you're using Python, right, or R, you're going to be calling out to a lot of libraries that are written in C. And so the thing is, Python code or R code running on GraalVM, we run in a managed environment, right? So you don't have to worry about stray memory access and whatnot. So that is all entirely managed. But once you call out to C, at that point it's C code, and then you're sort of essentially relying on whoever wrote NumPy, for instance, on having done their job correctly and not having seg faults and whatnot. And so, so the nice thing is with Enterprise Edition, we are able to sort of run that C code also in a managed environment. So essentially, we have an LLVM bitcode interpreter. So you compile that C code down to LLVM, and then you can run that in a managed environment just like any other Graal language. So you get sort of enhanced security in that sense, and then you obviously also have better access to support because it's a paid product. So we are actually working super hard on prototyping this, and we hope to be shipping very soon. So keep an eye out. Yeah, safe harbor, etc. So, but yeah, we are working on it, and we hope to have an update soon. Anybody else? Oh, please. Sorry, so is your question that if we can run Perl or PHP on GraalVM? In principle, absolutely. So we don't currently have implementations for Perl and PHP, but that's the kind of thing. I think so. The nice thing about GraalVM is adding new languages is easy. And so the languages we are currently working on are those that we perceive as people wanting access to them. But if there's demand for Perl or PHP, by all means, absolutely. All right, then. So we all have 13 minutes of our life back. All right, thank you.
Okay, all right. All right. Does it work? Sounds great. Excellent. Yeah, let's start. Thanks, everyone, for coming during this lunchtime. I appreciate it. You chose my talk instead of nice food. And I hope I will not disappoint you. Should we show the slides? It's connected here. Which one is this? All right, excellent. Yeah, so today we are going to talk about how we can master cloud-native Java without leaving what we as developers treasure the most, our code. And I assume everyone who came here prefers our beloved IntelliJ idea for Java, and we will see that it could be really helpful when we develop cloud-native Java applications. So a little bit about me. My name is Ivan. I work for Google Cloud Platform, and I work on Cloud Code for IntelliJ, which is a plugin for IntelliJ, and we support VS Code as well, which aims to make a development for Kubernetes and Cloud Native as easy as if you just were developing on your own local machine within your beloved IntelliJ. But first things first. What is Cloud Native anyway? There's a lot of buzz going on around it. That's hard to explain. It requires reading a 100-page book to understand this. Actually, it is not. Let's take a look here. Here is Cloud Native Foundation Charter itself. That's the core of the description of the foundation itself. And it's pretty succinct. It's really laconic and easy to understand. So cloud-native technologies empower organizations and us developers to build and run scalable applications in clouds. And it could be private cloud, on-prem cloud, or public cloud. Oracle Cloud, Google Kubernetes Engine in Google Cloud, AWS, of course. So for us developers, what's in red is a little bit more important than everything else. So containers, microservices, and declarative APIs exemplify this approach, along with immutable infrastructure, service meshes, and some other things. So it seems we need to put our applications into containers, potentially run them as a multiple microservices, and use declarative APIs to deploy this into cloud. And an elephant in the room in this cloud-native space is Kubernetes. You need to control Kubernetes with declarative API to run and launch your application in cloud. It's always good to start with a nice little story, so it will not be boring, and I will just talk about abstract stuff. So it's a tale of three developers and the idea. We're here in San Francisco, in Bay Area. Everybody works for a startup, wants to start a startup, maybe thinks about starting a startup. They started a startup. So what is the idea? Brilliant, voting as a cloud service. We live in democracy. There's a lot of voting and elections going on, right? We heard a lot about Russian hacking to election. I'm from Russia originally, so let's talk about this. They decided to build it really, hardened really well, 24/7 available. And of course, it needs to be a cloud service. It needs to work in multiple clouds. What could be better than build it in a cloud-native way and work with Kubernetes? Yes, Kubernetes is vendor neutral. You can use any cloud. You can run it on multiple clouds. You can even scale it and share it between multiple clouds. Perfect idea. But let's see. There are three of them. Two of them are Java developers, but one decided to step away a little bit from Java and chose Kotlin. Another one is decided to stay with Java and Spring Boot. And third one, he will help them with JavaScript. He will not be able to use IntelliJ, but WebStorm is not worse than IntelliJ. So they sat down. They were very experienced, just like us, all here in the room, I hope, experienced Java developers and JavaScript, and drafted this perfect, great, very short design. So the traffic will come via IP and domain name into an ingress, which is like a Kubernetes thing to route your traffic into a cluster. And the first thing is front-end service. So that guy who switched to Kotlin decided to use Kotlin. Cater is a server-side framework. Gradle is building this project. So front-end service will serve the root web page where people will cast their votes. And it will also serve results, a static resource where you can see results. When you cast votes, it goes to another microservice, vote service. And where vote service is hard the brain of this microservice application, we will keep count of our votes and notification service with a Node.js JavaScript app, which will use wonderful WebSockets to live update results page. So once you voted, you can see how picture, evolves and what's going on with an election. Perfect, great idea. So they decided to build these free microservices. They opened the IntelliJ, they wrote the nice implementation, they experienced developers. But what's next? Containers. Who's using containers here? Everyone, I guess? Yeah, Docker? Yeah, well, not everyone, but yeah, well, sooner or later you will need them because they're super cool. What is a container? Lightweight virtualization. You can run on your server, on your machine, as much things as you want, depending on the resources you have. And all of them are isolated. Very cool. But what do we need to do to put our application into a container? Well, first we know if we use Gradle, we can assemble the project, maybe same thing. OK, but then we need to put this into a container. So what is this? Is this command, the pretty standard thing to build and put it into a container? You build it, you use a Docker file, which is assumed to be here in this directory, and then you say, I want to tag it and put it into some container repository. Container repository, something like a Maven repository, put a container image there, and then Cloud Kubernetes pulls it from there. And you see that thing in the end, highlighted? Do you know what it is? This is supposed to be unique. Containers are immutable, which is great. Every image you build with a unique tag is never modifiable again. So you can reproduce your system. But we'll see what happens next. And you put this image, you push it to a remote repository. Then, potentially, you know a little bit about Kubernetes. You create a deployment, and you say, hey, kube control, apply this deployment, and now Kubernetes running on your cloud cluster will run it. And then you need to understand what's going next. So now we will not have direct access to the application when you run it locally in your IntelliJ. And now it runs in the cloud on Kubernetes. So you use kube control, you get pods to see if they're healthy. You port forward them, and so you can access the endpoint, for example, here, 8080, and then you get logs. So not bad. Let's count. I counted about 8 additional commands and approximately 3 CLI tools and 1 editor to just run your application. Do the same what you do in one click in IntelliJ, but you run in Kubernetes. What happens if I turn ahead like this? What does it look like? It looks like an infinite amount of time to me to pass an application from my IntelliJ IDE to Kubernetes cluster. And don't forget, all of those 8 steps needs to be repeated for all little changes and bug fixes. So you will not spend a lot of time with your code in your business logic. You will spend a lot of time on CLIs and configuration. This is actually not what we want as developers. We want to spend more time with our code. But this is not it. Declarative API is in YAML. So yeah, this is a nice dev process. So it's easy to see, right? We want to code maybe a little bit of kubeconfig and see our application, but in here, we just saw all of these extra steps are not what we actually want. So anyone heard of Kelsey Hightower? So he's a pretty vocal figure in Kubernetes world, evangelizing Kubernetes for quite some time. So it's sometimes better to just quote a famous person. Everything in the world of Kubernetes ends up in a YAML file. Absolutely true. And whole conference about YAMLs. It's called KubeCon. Absolutely true. So we will see a lot of YAML files. I hope you enjoy writing YAMLs from scratch, from zero. Who loves this? No one? OK, I hope someone would write it, and I will call him 10,000x programmer, because I can do that, and most of people I know can do that. But actually, there's an easy way to go with YAMLs. Most of them we write for Kubernetes are pretty standard. Those are just standard deployments. Those are just standard services. We just want to start our application in Kubernetes for the start. And we can use IntelliJ live templates to that. And it's just so easy to start with them. And very easy to deploy after that. We will see that. So we can solve this. But then next, debugging microservices. Once you have multiple moving pieces inside of a cluster, how do you debug? What happens here in this code in the middle? We use Spring Boot-based REST template, and we do exchange of REST entities, and we call, for example, this notification service, and we get a response. What if something goes wrong? Who is wrong? Who is right? Is this notification service issue? Is this world service issue? Maybe some other moving parts issue. So what could we do? We cannot just debug this locally because it's all running in Kubernetes. So multiple things we can do here. So first things first, unit tests. Of course, we should always do unit tests. So we can spy, stub, mock all of our remote dependencies. But what do we do when we do that? We base it on our assumptions. We only know so much about current state of the service we spy and stop. But what we've changed, what is a very agile process, like in startups, it's always changed all the time. And hopefully we move in high speed and they break things all the time. And even if our unit tests pass in cluster, something is failing. What else? Some people use local Kubernetes environments. You can do that on your own laptop and set up and see what's going on in your microservice application. So Minikube, Docker, some people use Compose. Sometimes they think Compose is a little bit better, a little bit easier to set up than a whole Kubernetes environment. But there's a problem with this as well. You only have so much resources on your local machine. Imagine you have tens of microservices, or they're pretty heavy. They have functionality, they need a lot of memory. So you need a large virtual machine to run them. And then you might use wonderful cloud APIs, Cloud ML, Cloud AI, Cloud Speech Recognition, Cloud Vision. Everything like clouds offer so much functionality nowadays, and you will use it no matter what. And when you run it on your local Kubernetes cluster, you will just not have that easy access to those cloud APIs. So finally, it's probably the best and most recommended way to do that. Have development environment, development Kubernetes cluster or a namespace, completely identical to your production. If you heard of 12-factor application, one of these factors is to test and develop in the environment completely identical to your production, which is, again, would be hard to do because you don't have direct access to your development cluster. You need to set up a specific debugging images, to set up a specific debugging ports, port forward them, and do that all manually if you want to connect and debug right on your Kubernetes cluster. So they were pretty frustrated. But they found Cloud Code for IntelliJ, NVS Code. And they figured out all the issues that they saw. 8 additional commands to build containers. Not ability to debug, single-click debugging from an IntelliJ or other IDEs. And all this mess with declarative APIs and YAMLs all could be pretty much solved when you use Cloud Code. So let's see. Cloud Code allows you to build highly scalable native applications. We integrate a set of tools for you. They will help you to quickly redeploy, rebuild, retag your container images, push them into a cluster. We will allow you to live debug your application on Kubernetes cluster with just one click, as if you were just running your application locally in your IDE. So we give you more time to focus on writing and evolving what matters to you as developers, what matters to that startup developers, what matters to me most as a developer, my code, my business logic, my idea. So now it's demo time. I will impersonate those startup founders, one Kotlin developer, one Java developer, one JavaScript developer, and we will see how hard or how easy it is to put your application to work in Kubernetes in cloud-native way. So just to refresh your memory, this is what we're going to see. First, I'll play the Kotlin developer. This can be a front-end service. It just serves static resources for those 2 pages. Then vote service, the most important part, the brain and heart of this microservice application, Java, Spring Boot, Gradle. And notification service, Node.js application that will just use WebSockets to live update the results page. Sorry. OK, let's start. So first things first, let's go and see how do you get Cloud Code. IntelliJ, preferences, plugins. I already have this plugin installed, so it's Cloud Code is here. But if you don't have it, you just go to Marketplace, and type Cloud Code, and you will find it here. Also, for this demo, I installed the Kubernetes plugin from JetBrains, which is pretty helpful to work with YAMLs, as we will just see in a minute. So this is my code. I'm now a Kotlin developer, and I use Ktor framework. What's good about Kotlin, you can use inline functions to create a domain-specific language. And here, instead of calling some functions on applications, some methods, I just say, hey, this is my routing, this is a static resource, this is a static resource. Beautiful, only a few lines of code, and my web server is ready to serve. And it's working. I can just run it locally from IDE. And so what's next? We will need to create a Docker file. Docker file is that set of instructions to put your application and all of the dependencies into a container, basically just to create its internal file system. So I created this Docker file, and I can say it's pretty terrible because it just copied locally built jar file, and at least I based it on Alpine, not on Ubuntu or some operating system base. But then again, I doubt it's even work, but I'll just copy it from Stack Overflow, right? That's what you do when you don't know something. I'm not sure actually what to do with Docker files. There's tons of documentation on that. Is that supposed to be so hard? We'll see. But now the YAML, I don't have any YAML here. How do I deploy? This is what I do. I say create, hey, this could be my Kubernetes resources. And now I create my YAML files. I heard you need to create deployment to deploy in Kubernetes. And this is right. This is my deployment YAML file. Yeah, let's add this. So where do I start? It's so complicated, but we have Kubernetes plugin installed. Just use snippets or live templates. If you start with Kubernetes deployment, here is it. 1, 2, 3, it's done. I need to know, well, I'll say it, yeah. This is going to be my front-end service. And you'll see all the labels, everything is created for me automatically. Now the image name. I will use Google Container Repository for my image name. And this is my project. If we use any other cloud, any other image repository, Docker Hub, you just put for Docker Hub your, I think, docker.io/name/container image. So I say, yeah, this is my container image. And that's it. I mean, everybody loves changing replicas because that's the amount of replicas that will support the execution of our code there. And I'll put 3 just to be sure we'll handle all the world's laws when everybody starts using our voting service. So this will run it, but it will not expose the port. So we'll need a service. And again, I'm not going to use my bad YAML skills. I just use snippets. So everything I need to do is type a file name. And this time, instead of deployment, I say, hey, Kubernetes service for me. Excellent. So I will use the same name. Take different deployments, different object types in Kubernetes have same names, and selector will match that selector of deployment we just created. So we'll use the standard HTTP port. The target port will be the one I used in my application. And type node port is OK, but I just need a cluster IP because I don't need any load balancing for it. So excellent. So what's next? We go to CLIs. We just try to deploy. What do? No, we don't leave our IDE. We go Tools, Cloud Code, Kubernetes, Add Kubernetes Support. 1, 2, 3. What do we see here? We have 2 new run configurations. Kubernetes deploy, Kubernetes continuous deploy. What is the difference? Let's add it and see. So Kubernetes continuous deploy. I hope you can see it well. What it does for you, it's something like quick fix, quick debug mode. It runs continuously, and when it detects changes in your code or your configuration, when you save it, it will automatically tag, push, and redeploy it for you. Forget about changeable version numbers. Forget about pushing into repository. Forget about redeploying, reapplying your Kubernetes configuration. Everything will be done for you. Just add a change, save, it will be redeployed to your Kubernetes cluster with all your Kubernetes manifest. And single deploy is just what it is. The single deploy will just do it once. And let's tail logs once we deploy. And for continuous deploy, let's keep deployments when we finish. So I think we're ready to go. But we also need to know what's going on with our Kubernetes cluster. Do I even have it? Maybe I do. Do I need to go to some other dashboard, leave my IDE in code? No, I don't. Here on the right, you see a set of tool windows. And one is this Kubernetes Explorer. So I see a lot of my clusters. So this is clusters. And for some of the clusters, I have one context. For some of them, I have two contexts. By the way, anyone knows the difference between context and cluster? It's easy. So cluster is actual physical cluster, right? A set of nodes that run your workload. Context is something from world of kube control tool. Context is just a cluster, a way to access this as a user, and a namespace you want to put everything into it. So, for example, for Docker desktop, I have two contexts for some reason. I think it's a Docker bug. But now my active context is code one on Google Kubernetes engine. Let's take a look if it's actually available. So it shows me that my default namespace is what it is, the current namespace in my context, and it will show me that I'm running a thing called Ambassador. This is the thing that will handle our ingress, but nothing from our application yet. Great. So let's try to deploy it and see the logs. So what we see here, well, it's going to be really fast because I apparently built it before. But it's like, yeah, it took like 1 second, but there's an error in there, container terminated, no man manifest, because I think I had a very bad Docker file. I didn't include dependencies, and I just didn't think about much there. Is there a way to do that again? I'm not a Docker file expert. I just want to put my Java application into a container. And there is. Let's see. This is called Jeep. Anyone heard of Jeep before? Okay, good. I hope you will like it. So now with Jeep in one turn, you become container experts. You don't have to think about Docker files anymore. Do this. Apply the plugin for Gradle or Maven. And if you want to build a separate image, just do Gradle Jeep or Maven Jeep target. What it does for you, it analyzes your Java project. It splits it into resources, classes, and dependencies. It will never rebuild without need. It will use carefully selected base image. It will build very optimized small container image. And you don't need to do anything. Just include it as a plugin for your project. So let's do that, because Cloud Code supports Jeep as well. I'm going to my Docker file. What should I do with that? And now I need to go into a configuration of Scaffold. Scaffold is the engine behind what Cloud Code does for you at Kubernetes. Why it's good to have something below the IDE. This is a CLI tool. We don't need to touch it from working IDE, but when you want to transfer your deployment debugging sequence into CI/CD pipeline, for example, you can reuse the same Scaffold configuration, which is Scaffold YAML by default, and the same steps as you use in IDE. So your development process is not separated between IDE and CI/CD, and you just use the same process. So everything should match in your IDE and your CI/CD pipeline. So what I have here, I have image built from Docker file. Everything I need to do, I just say Jeep Gradle. It's the Gradle project. And that's it. Hopefully, Jeep will solve this issue for me, and I'll forget about Docker files and everything. OK, it found cache, tags. Let's see. Wonderful. I see some logs. So logs are streamed for you automatically from your Kubernetes cluster. You don't need to go to CLI and stream logs and just try to find out where are you, especially if you have multiple project windows open. I don't think I see any errors. So it should be good. I also can go into my Kubernetes view and say, hey, refresh pods, and I see my free instances. How about deployment? Was it deployed? Yes, I see front-end service and services. Let's update it. A new front-end service. OK, so this is my domain name, what-k8s.org, that I set up for this voting. Previously, Ambassador told me, like, the ingress component, there's no health upstream, no microservice to handle the address. Let's see that about now. Excellent. I think we just started the front end, but it will not work because the other components needed. Yes, service unavailable. Let's continue. So now we're switching to our Java developer. Good. This deployment is done. So this is, again, the brain and heart of our application. For the simplicity of the demo, we are stateless here. So this The votes will be kept right here in hash map, so not really a persistent solution, but it's really easy to understand what's going on here. So this is a simple Spring Boot handler of this mapping, and it should just accumulate votes and notify notification service. So again, it's working. I tested it locally. What do I do to put it into a Kubernetes cluster? First things first, create YAML resources. I already did this. We just saw how to use it with snippets. Exactly the same. I spent maybe 3 seconds creating those YAMLs, never thinking about mistakes, because I just used pretty much standard snippets, and they work maybe, I don't know, 80, 90% of the time. I just used appropriate ports, and the image name is different for that. Excellent. And again, a Docker file. Again, a terrible Docker file. But we already know how we fix this for Java projects. So we go Tools, Cloud Code, Kubernetes, add Kubernetes support. And we see what we want to see. A target in IDE to deploy or just quickly iterate on Kubernetes deployment and the application here. So again, we'll keep the deployments and tail. And how do we use Jeep? We'll go here and say build it with Jeep. All right, in this crust, deploying. And again, I built it before, so that's why it's so quick. But we'll see with the change, it will be so quick as well. And again, we'll see standard Spring Boot logs. Everything's starting. I think everything working so far. Start application, perfect. I'm staying in my IDE again. Do I see me using any CLIs yet? No? No one? No magic? Yeah, I'm just developing and deploying to my Kubernetes, staying in IntelliJ. Nothing extra is needed. Okay, we deployed. Let's go check. We have an Explorer here as well. How about deployments? Do we have it here? Yeah, what service? Excellent. So now we go to our JavaScript guy in Node.js application, here the web storm. So unfortunately for Node.js, there's no alternative like Jeep yet. Maybe it will appear soon. But Dockerfile is a little bit simpler. We just need to copy those package and GS files and then run it from a standard Node image. So we'll use Dockerfile for this. So we need to run and just to start this HTTP server that will communicate with our word service, receive the updated words from it, and notify everyone connected via WebSockets. Again, tools, Cloud Code, Kubernetes, add Kubernetes support. And then again, it's not IntelliJ, it's WebStorm, and the same will be available in PyCharm, Golang, whatever application you want to use. Great, I see my targets. Everything is here. I'm deploying to my active context, which is Code 1 and Google Kubernetes Engine. This is my little cluster that I work with. I'll keep my deployments in continuous mode, and I'll tail deployments for now. Let's deploy. Again, it's going to be really quick because I built it before. Let's wait for some logs. Logs, listening. OK, great. We'll listen for that. Again, I didn't leave in IDE or IntelliJ or WebStorm for that. Let's see if we have Kubernetes Explorer here. Yes, we do. How about services? Do we have this notification service here? We do. We can even stream logs from service or from deployment, just to be sure. Yeah, logs are fine. Everything seems fine here. I can control the overall development process, the picture that works here. Excellent. Where is it? I'm ready to go. I like Cloud Code, Jib, and Scaffold. Is it working? Looks like it's working. Anyone wants to try? Maybe you vote for something else? Yeah, vote. Let me check. Maybe I'll vote from my phone. Let's see. I'll vote for Google Kubernetes Engine. And Scaffold too. What's happening here? I think we have a problem. It looks like there's a bug here. And now the dreadful thing, debugging microservices on remote cluster. Unimaginable. Try to imagine this doing this manually. You don't have access to it. You cannot connect to debug mode. And images that you just deployed, they just can't be run in debug mode. You need to recreate all of your YAMLs, adjust them, use new versions, put your application debug mode, Java tools options, port forwards. It is a lot of work. And after that, be sure to clean that up. It's a lot of tedious work. But look here. Well, first aspect was JavaScript, right? Java is much better. So they say, well, maybe that's a problem with your JavaScript. And say, okay, what do I do? Maybe I put a tons of log messages or redeploy that manually. No, look at this. We got a debug button available right here in your IDE. And this is notify method. And then say, okay, will it work if I just want to debug this? Okay, we're connecting, we're listening, and it seems like we're working. Let's see what we get here. If we go and cast another vote. For example, these should have more than one vote. All right, we hit a breakpoint. What happened here? Yeah, timeout, of course. What happened here is just quickly, behind the scenes, we converted your application into debug mode. We changed all the Kubernetes manifests, your application entry point, redeployed it into Kubernetes cluster, and port forwarded that connection to you, to your IntelliJ or WebStorm IDE. Now you have full access to that Google data center, to that application running to you, to the all state you have there. Just do that from your IDE as you would do locally. Everything is here. Perfect. Now, let's see. I'll do that. Yes, I said request body. So what is request body? It's a Cloud Code 1 and Jeep 1. It shouldn't be that little. We should have more. So it seems it's not my problem here in JavaScript, says the JavaScript guy. It seems something is wrong with vote service, which sends the updated information. Okay, is it available for Java? Let's see. Let's go to vote control. And continuous mode. Yes, the debug button is here. So let's see, will we be able to repeat this magic here in Java? We're redeploying. We did a new version. Don't worry. Your production version or tag-specific version, nothing will change. Everything stays the same. This is completely separate. It's completely separate image that you just use for debugging. Okay, let's do it again. Yes. Now in debug mode it's not responsive. Yes, it's again here. And again, exactly the same for Node.js, exactly the same was done here. We're now looking into the state of things in Google Data Center and Google Cloud. Everything similar could be done for any cloud. AWS, your own on-prem cloud. We're now here inside of the server, inside of the pod and container running on Kubernetes. Let's see. Probably have a woods. Let's waltz a little bit more. Okay. So we have some votes here. We have Cloud Code 4 and Jeep 1. Okay. So we're adding them. It seems fine. Let's run to cursor here. And we are running and sending the votes to our notification service. I'm pretty sure I never make bugs. Who made bugs, right? I mean, I never introduced bugs, said the Java Spring Boot guy. And he says, okay, so notification response. What does this notification server response? He said Cloud Code 1. But it just was 4. I think even 5. What's going on here? Anyone knows where the bug is? Maybe? It's hard, right? Well, I know where the bug is. I'm sending new votes instead of accumulated votes here. Yes, and even logging the new votes. All right, I found it. Sorry, my bad, said Java Spring Boot guy. I hope I fix it. So let's do continuous deploy in case we'll find any more bugs. So continuous deploy again. I will deploy my application, and also the call code will just watch all of my changes and redeploy as I need it. So I'm redeploying. Succeeded? Great. So just changed what I sent to notification service. Instead of new votes, accumulated votes. But I also see the problem here. I'm logging not what's needed to be logged. So I say, hey, just log votes, and I do save. What do we see? Again, retagging, new tag version, redeploying, re-updating, everything starts again. I don't need to go and do anything. And I also can always go here and see if everything is fine, and stream logs, and see if I have enough. I'll see. Excellent. Now we also saw what services, because one was going down, one was going up, now one is left. Fingers crossed, fingers crossed. How about this? Okay. Better. So you want to help me here? What dash Kubernetes? Choose something that you like from a presentation so far. Oh, you like Jeep, excellent. Anyone else? Take out your phone, What dash Kubernetes. Oh, Jeep, Cloud Code, wonderful. You know, this voting as a service is not bad. I think they should start selling. It just works. And look what they did. When problem arrived, they didn't spend more than 10 minutes to live debug it on the Kubernetes cluster in a remote data center, looking at an actual problem. Well, probably it's not the way to do it in an election night, but it's definitely a great way to quickly identify problems without leaving your idea. Excellent, thank you. And well, this is just a set of candidates that I chose, but we're here in democracy. How about new candidates? Kotlin, anyone like Kotlin? Want to add Kotlin? Anyone else? There's a lot of talks of GraalVM. What do you think about GraalVM? Good, bad? Let's try it. I hope this will be anonymous voting, right? No one, everybody is very, very polite. So let's see. Now, everything isn't just front-end service. I'll go and say continuous deploy. And it should be rolling updated into a new application. So here I have some settings. Yeah, sorry for my copy paste. So it will be easier. So let's say Kotlin, maybe you like Kotlin. So let's say, how about GraalVM? And results should show this thing. Where are the results? It's right here. Look at the logs. Everything as I change is rebuilt automatically and deployed. Again, safe. Let's take a look. Oh, OK, it's here. I like Kotlin a little bit more. And then, for the simplicity of the demo again, we haven't used any Redis, Memcache, or whatever it is. Everything was saved in vote service, so our previous voting data is lost. So we need to vote a little bit more again. So I like these things a little bit more than GraalVM. So let's see. Oh, great. So let's see. Maybe Kotlin and GraalVM will be a little bit more popular. I don't know. I'll vote a little bit more. I like Kotlin because we are using Kotlin in development this plugin. Great. Yeah, I agree. Scaffold is good, especially in conjunction with Cloud Code. And in Jeep, you can do it a lot. So yeah, I understand you not using it. Many people not use anything from above, but I definitely recommend start using it. All right. So recap of what we just saw. You can now control everything in your Kubernetes cluster right from your IDE. And again, have I used any CLI tools? Have I switched from my code? Have I went to some web dashboard? No? No magic. So what else can we do with Cloud Code? You can develop in remote cloud on any Kubernetes cluster, just as I mentioned, Kubernetes engine from Google, AWS, Oracle, of course. You can do it on local Kubernetes. What's good about local Kubernetes cluster? It gives you absolutely the same feeling. And it will not allow you to work with it easier than a remote one. You will still need to port forward. You will still need to run everything in debug mode if you want to debug. And with Cloud Code, it's very easy to do that, even on a local Kubernetes. We also have profiles. We haven't got enough time to look at that, but you can create custom profiles if you want to custom build your image, maybe include custom Kubernetes resources for that. Container builders with a Docker, Jeep for Java. You can use Docker Hub, GCR.io. You can use Amazon's container registry, everything you know the address, and you have authorization for it. Cluster browsing. You can browse your cluster, stream your logs, describe your resources. You can refresh and create them and view it right from your IDE. Debugging. For now, we have Java and Node.js. It works just like that. And Go and Python is coming soon, hopefully end of this month. Editing, we have a rich YAML support. What we saw was a great functionality from JetBrains Kubernetes plugin. We have a lot more. We have a lot more. Knative, Kustomize, and MLE is coming. We'll have Istio, which is a great service mesh, Cloud Build, and we have a lot of support for Google Cloud APIs. And deployment, I show you how you can use continuous deployment for quick fixes, quick updates. You can use manual deployments, just run it once. And also, we support Cloud Build, which is another interesting feature from Google. You can just push all your sources into cloud and build it there. And again, Cloud Code supports it. You don't need to leave your IDE to do that. And just a little disclaimer, the Kubernetes cluster browser, it's already available in VS Code. For IntelliJ, it will come end of this, like probably in 2-3 weeks, we're releasing beta of Cloud Code. So all of that features that you just saw will be available there, plus a little bit more. Which is just exciting release coming in a few weeks. How to get it? IntelliJ, just as I saw, just preferences plugins, go find it on Marketplace. Visual Studio Core, again, same thing. We got GitHub repositories for issues and enhancements. Please, please come file issues. We watch it every day, every hour. Any issue that you run into, you want to use it, you find it not helpful, please let us know. We're still in active development. We have a lot of crazy ideas. We would love to hear from you. This is a documentation site. You will find a lot of quick starts and tutorials there. So thank you. Thank you. This is my credentials. This is demo address. And thank you very much. I hope now you know how easy it is to master Cloud Native in IntelliJ and other JetBrains IDEs with Cloud Code. Thanks. Questions?
Sure. What crazy ideas?
We want to, integrate that with resource browser. We want to provide more feedback. For example, you will see live on your IDE what's happening, what's going on with your deployment, what pods are coming out, the state a little bit more highlighted. So the tree will be more animated, live. Maybe logs will be redesigned a little bit more into a separate log viewer. So we can use Stackdriver if you work on Kubernetes engine and things like that. So because logging monitoring is always seems to be a hot spot for Kubernetes. Anyone has any ideas, just please come and file them on GitHub. Yeah, you're welcome. Thank you, guys. Thanks again for choosing me over the lunch. This is exciting.
Hello. Does it work? It works. Yay. We have audio. Oh, that's okay. Okay, thank you very much.
Video slides or anything that needs audio?
No.
Okay.
Okay, so we have a couple of seconds left before it's half past. Since we already lost one audience member, I think I'd better get started. So, hi everyone, and welcome to this talk. My name is Jesper Wilhelmsson, and I work with GraalVM development at Oracle. And in this talk, I will try to guide you through how to become an OpenJDK contributor. So let's see if this works. Yay. So the OpenJDK project, let me start with a few words about the project as such. The project governs the Java programming language and the Java runtime. And Oracle is one of the main contributors to OpenJDK, the largest contributor, I'd say. Oracle maintains the OpenJDK project and hosts infrastructure for testing and source mirrors and such for the open community to use. The project has several other big contributors, of course, both large companies and personal, like individuals who are contributing to the project. The OpenJDK consists of groups who work together around some kind of common interest. This interest could be technical areas within the JDK, or it could be like aspects of the programming language. So there's a couple of examples there, but each of these groups maintains their own mailing lists, and they can also have like wiki contents for documentation and such. And each of these groups may also sponsor projects. So a project within the OpenJDK is a collaborative effort to produce a specific artifact. So there are a number of different projects. One of the more famous ones is the JDK project, which is where the current implementation of JDK 14 is happening. We also have the JDK updates project, where JDK 11, for instance, is currently living. Projects can produce artifacts like features in the language or features in the JVM. The projects can also be a collaborative effort to produce, investigate tooling or produce tooling around the OpenJDK to help with development. And there can also be projects like the Duke project, for instance, where we collect images of our famous Duke mascot. So a participant in OpenJDK can be a member of different groups and have different roles in different projects. So this is just an example of that. So the different roles that the person can have in these projects. Well, if you're new to the project, you would start out as an author. An author is someone who is contributing, like helping out in mailing lists and maybe have suggestions for how to implement stuff. But the author is not allowed to push changes directly into the code repository. Any changes made by the author must go through a sponsor. Once the author has contributed a couple of significant changes, there is a vote among the committers of the project to see if this author can become a committer. So all committers get to vote, and if it's deemed to have committed the good enough stuff, then everyone says yes, most often. The same happens later on. If a committer has contributed a large amount of significant changes, he can become a reviewer of the project. So the committer is allowed to push code into the repository. The reviewer is the one with the actual power who has is determining if a change is good enough to actually go in. So you need to have the reviewer's approval before you can commit something. Each project also have a project lead who is basically any committer that is suitable to lead the project. If you're interested in reading more about the actual rules behind the project, you have the OpenJDK bylaws that is governed by the OpenJDK governing board. So this is available on the OpenJDK website, so you can read more about it there. So let's see how to actually become a... Whoa. Okay, I should not touch that. The open community consists of people like all of us, people who just want to make Java better. And to join the community, the first step would be to go to the Java OpenJDK website and have a look at what projects there are, read through the descriptions of these project pages and see if there's anything that sparks your interest. If there is, you go to the mail manager, and subscribe to the relevant mailing lists for these projects. And then you can start to actually participate in that project. So let's see how you actually can contribute. So contributions can be many different things. You don't have to push code to actually contribute. Active participation in the mailing list is one way to contribute. You can be a part of the design discussions, you can be part of reviews and how to implement and design different features or functionality. You could also be active behind the scenes, so to speak, and help out with the practicalities around getting actual releases in place and producing the artifacts. You could also do coding, of course. And for the rest of this talk, I'll be focusing on how to contribute with actual code changes. But first, I should also mention that you can actually be contributing to the OpenJDK without spending any time or effort at all. And that's by actually buying a subscription. Buying a subscription, if you have built your business around Java and you are actually making money of Java, then a subscription could be a way to just encourage the developers and maybe say thank you. So before you can actually push any code into the OpenJDK source repository, you need to sign the Oracle contribution agreement. So using this agreement, you will allow Oracle to build and distribute your code, basically. So it's a way of sharing the copyrights to your code. You will still have the copyright, but you're allowing Oracle to also use it. You can sign this as a private person, or an organization can actually sign it for its members. So it could be the fact that you actually already are included in this if your employer, for instance, have signed this agreement already. So a good place to start, if you want to know the process behind and the workflow, is to look at the OpenJDK Developers Guide. So this is available on the OpenJDK website. This, I should mention, is still a work in progress, though. So there are parts missing, and that's actually something that I will be working on once I get back after Code 1 here to try to fill out some of the blanks in this. I should also note that there are differences between how the engineers work in different parts of the JDK. So on this page, for instance, on the OpenJDK wiki, I have documented most of the process around how we work in the JVM development team. This is getting slightly outdated. You can see on the date, well, it's maybe too small to see, but it was updated more than a year ago. So it's getting slightly outdated. My goal here is, of course, to unify these processes with how we work within the entire JDK and publish this within the developer's guide. So let's try to find something to work on. If you want to contribute, one way to get some stuff to work on is to go to the bug database. So the JDK bug system, JBS, is openly available, and here we have tickets for all the bugs and enhancements and everything that we work on within the OpenJDK project. You can query this database. It has a fairly advanced query language that you can use to find all kind of different issues. A couple of labels that are good to know is the starter label and the cleanup label. So the starter label is something that we put on changes that is well contained and could be a good start for someone who is new to the code base. The cleanup label is used for changes that is pure cleanup, that have no like semantical changes, but just renaming some stuff or reorganizing code. So that can also be a good start if you want to get to know the code base. If you want to read more about the labels in JBS, there is a label dictionary on the OpenJDK wiki. This is currently located in the hotspot part of the wiki, mainly because the JDK doesn't actually have any wiki pages of its own, the JDK project. But the labels are the same throughout the JDK and should be used in the same way all over. So if you have an idea of your own that you want to suggest to the OpenJDK, the best way to introduce it to the community is by sending an email to the appropriate mailing list. You would describe the idea and why you want to make this change, of course. The community is a fairly including community, and people are usually nice on the mailing list, so you will most likely get a lot of help analyzing the pros and cons of your suggestion. If it's a small change, something that would require like less than 2 weeks of engineering time is the usual target for that. You could file an RFE. So this is a simple issue in the bug tracker system where you just type down what you want to do, more or less. For larger features, stuff that would take more than 2 weeks of engineering effort, or something that might require high visibility or be like a controversial change, something that people are likely to disagree with you on, you would file a JEP, enhancement proposal. So it's also a ticket in the bug system, of course, but it has more of a template for you to fill out and how to actually do it. And there are more places for discussions and descriptions in this. I should say that the JEPs have gotten an improportional amount of visibility or something. It seems that for any given JDK release, the list of JEPs is the things that people focus on to say what has changed in the JDK. But note that the difference between an enhancement and a JEP is not based on how much the change actually contributes to the OpenJDK. It's based on the amount of work required to implement it. So there could be, and usually are, a lot of RFEs that are just as important for the Java, for the OpenJDK, than any given JEP. So it's a good idea to look at those as well if you want to know what happens in a release. OK, so I have a feature here that I want to implement. So you probably know about big endians and little endians. And you know that if you want to communicate and send text between these two groups of people who eat their eggs from different ends, you need to swap the first and second part of each word, right? So I want to implement the support for this in the string, Java Lang string class. So I make this an enhancement, I believe this to be quite not that much work. So in order to actually do this change, I need to download the source code. So let's go ahead and do that. The source code is kept in a Mercurial repository. So using just a simple clone command, we can download the entire code base. So this will give you everything. It's the JDK libraries, it's the JVM, it's all of it, documentation and all. There is also a Git mirror that you can use to download the source base. But please note that this mirror is read-only, so you will not be able to push any changes into this repository. When it comes to IDE support, it's a little bit tricky because the OpenJDK source base is so large. As far as I know, no IDE is able to actually contain all of it and help you debug all of it. And one of the biggest problem here is, of course, that we have both Java code in the libraries and C++ code in the VM. So usually, IDEs don't like to work on different programming language like that at the same time. There is support. I mean, NetBeans is fairly easy to use if you want to work on the Java part of the libraries. IntelliJ, the same. We have some script that can be used to build a project for IntelliJ. I believe that this script actually asks you which modules you want to use and include in your project because there is simply so much Java code that it won't be able to handle all of it at the same time. If you want to work on C++ code, you have a project for Oracle Developer Studio that is included in the source base. And when I asked around in the office, my closest colleagues, just to see what IDs they were using, you can see there was a fairly wide distribution. And basically, you can use any text editor. I mean, it's just text files, as always, when it comes to programming. So use your favorite ID. If you know someone, or if you yourself is very handy when it comes to IDs and how to do these things, the OpenJDK really could use you as a contributor. Because currently, we don't really have many people that know how to use, how to build IDE project files and maintain these things. It's fairly low priority for most people at the moment. So if someone would like to pick that up, that's definitely an area where we could use more contributions. OK, so I just put up my random source editor and open Java-line string to make my small change here. Try to make it look basically like the code surrounding code. The coding style guide in the developer's guide is currently empty, unfortunately. So just try to make it look like the other code. I mean, you know what looks good, right? Everyone has the same idea about how the code should look, I'm sure. OK, let's try to build this and see if it actually works. So in order to build, we first run the configure script to configure the build. The configure script will require you to have at least JDK 12 installed to use as a boot JDK when compiling the Java classes. And that's when building JDK 14, I should say. There is also a number of different requirements for tool chains and some additional packages that is used to build the JDK. The configure script will tell you what is missing, of course. And in most cases, it will also tell you how to actually get hold of the packages that are missing. So it's a very helpful configure script. Then we go ahead and run make. Make images is a target that will build the entire release image. So that's something that is fairly close to what we actually release as early access builds. It will not have any debug code in it. There will not be any search or anything like that. It will be an optimized image. So if you want to do some serious testing or debugging of the JVM or the JDK, you would most likely want to run with some higher debug level. So you can do that by running configure with this flag with debug level. And there is a target that's called slow debug that will basically enable everything. So there are search enabled, there are debug code, there is no optimizations enabled. So that's most likely what you want to use within a debugger, for instance, when you want to step through the code. OK, so once we have built it, of course, we need to test it as well. Some changes might actually be enough to build the code to see that it worked, if you do refactoring, for instance. But most often, you will actually need to run some tests to see that the code actually works when you execute it as well. So the JDK, the OpenJDK project, provides two different test frameworks that you can use for these reasons. So J2Reg is for Java regression tests, and it's used for basically, well, at least most testing that is provided. All the tests that is in the OpenJDK project are written to be run with J2Reg. We also have support for Google tests, so that is mainly used for C++ unit tests in the JVM mostly. We also provide a mercurial forest called the submit forest, where you can push your own changes for testing. So you push your changes there, and we will automatically run testing on your changes and provide some kind of result back to you. So J2Reg, let's look at a little bit more at the details. As I said, this is the regression test harness used by the JDK. You can download it from, there's a link there, OpenJDK website, which has the documentation as well. The tool itself is provided within the Code Tools project, which is where a lot of the tools that we use to build and run the JDK is contained. You can configure your build and tell it where this J2Reg installation is done. And if you do that, you can use make to run J2Reg tests with the run test target, as shown here. You can also use J2Reg as a standalone tool to run J2Reg tests. You would then have to provide the JDK with this JDK flag to tell it which JDK to execute. So the Google test, no, OK, sorry. I rearranged my slides. OK, so this is a small J2Reg test that I wrote to test my change. Basically, this is a clean Java class, which has a main function method that is just executing the code that I want to test. You can see that we throw a runtime exception if the test fails, if we don't meet our expected results. And the test harness will catch this exception and report that as a test failure. This test uses two different tags, J2Reg specific tags. There's the test tag and there's the summary tag up in the comment above the code here. The test tag basically tells J2Reg that this class is a test. And the summary provides some short description of what this test is actually doing. There is a lot more of these tags. Those are all described in the J2Reg documentation. And you can, for instance, tell J2Reg, or actually the user more, which bug that this test is a regression test for. You can tell J2Reg about different dependencies, stuff that needs to be fulfilled for this test to actually be usable and be executed. So you can require different operating systems, memory requirements, or anything like that. You can tell J2Reg if it has to use other modules within the Java module system. And you can tell it to use different command line flags and run the test in several different ways. So one test, for instance, can have several of these run tags in the same test if you want to execute the test in several different ways. So now, the Google test framework. So as I said, this is mainly used for native unit tests in the VM. It's used to test data structures and simple functions within the code. The good thing about this is that it doesn't require the JVM to be running when you execute the tests. So you can actually test data structures that would be very fragile to play around with if the JVM was running. So in the directory test hotspot, you will find a lot of tests that is using the Google test framework for testing the VM. So the submit repository, as I mentioned, you submit your changes here to get them tested on a wide variety of platforms. You do that by creating a branch. So basically, you clone the repository, you create a branch and push your code into that branch. And then when you submit it back, it will run all the tests on your modified JDK. The name of the branch, there is a pattern there that has to be fulfilled. So it basically starts with the bug ID of the change you are testing. And then you can add a small substring if you want to, like version 1, version 2, or things like that. But usually people use the same name, just the bug ID, for instance. And then you can push several times into the same branch and, of course, get it tested for every new change you make. So you don't have to come up with a new name every time you want to test something new. OK, once you have tested your change and made sure that everything works, you would, of course, like to have some reviews here. Because someone needs to verify that your code is good enough to include into the project. The request for review, the RFR, is sent out to the proper mailing lists. And if you have something that the change is actually modifying code that is not really obvious from the title of the bug, you might want to call that out in your email to make sure that the right people is actually reviewing this change. The subject of the email usually starts with an RFR and a bug ID. And it's also common to add some this extra large or extra small, just to give a hint of how big this change actually is. The email itself should contain a short description of what problem you're fixing and how. Any issues that things like anything that is resolved in an unusual way would be good things to highlight in your email. Language constructs that's not commonly used in the source space. If you, for instance, use some new C++ thingy, if you write code in the VM, or start to write some really weird Java code in the libraries, it's a good idea to mention that in the email as well. Also, of course, if there are places in your change where you yourself feel that this is very complex code, it would be very good to write that in email as well. Always include a link to the JBS issue. Always include a link to the patch. Or if the patch is small enough, you can actually include it in the email itself. Please note, though, that the OpenJDK mailing list do not allow attachments of this kind. So you cannot attach the patch like a diff file to your email. It has to be included in the actual body of the mail in that case. Also tell what kind of testing you have done. And also, if you consider this to be a trivial change, I will return to that in a minute, what that actually means. But that should be called out in the email. And also, if you are an author, this would be the place to ask for a sponsor to actually push your change. The tool that is currently mostly used for producing diffs and for reviews is called WebRev. Again, this tool is found in the Code Tools project. So you can download it from there. And it produces a bunch of different diff formats as a bunch of HTML files that you can publish on a web server. So that's most often what happens. People upload that to a web server and send a link to it in the email. So each of these reviews has to be open for at least 24 hours before you push your change. This is because the OpenJDK project is a global project. We have contributors from all the corners of the world. And to be inclusive and make sure that everyone has a chance to actually see the change before it gets pushed, we have this rule. There is a notion of trivial changes. You can call out in your email, as I said, if something is really small, like you fix a typo in a comment or something like trivial. These changes do not have to wait the 24 hours, but you must have approval from a reviewer. And then I mean a capital R reviewer, someone who actually has the reviewer role in the project. That person has to agree that this is a trivial change before you can actually push it under this rule. Also note that the definition of what a trivial change is may actually differ between different areas. So make sure that you read your feedback if you get any. Oh, you will get. I promise you. You will get feedback if you send something out for review. And also remember that the reviewer wants to improve the world just as much as you do, but just in a slightly different way. So even if the reviewer says in his reply something that sounds just like weird, make sure that you understand what the reviewer actually means before you reply. And be polite, even if you don't agree with what he's saying. After all, we want the community to hold together and be a friendly place to live. So always be polite. It's important. It's not very uncommon, actually it is quite common, to get replies as you are in the area. Do you mind fixing this as well? Don't be afraid to say no. Even if you're new and there's some senior person saying this, say no. If you make unrelated changes in your patch, the JBS issue must be updated to describe these changes as well. And really, for the sake of sanity, we want to have like every unrelated change should have their own JBS issue to make the history clean and make sure that everyone understands what changes are going in. So once you have your reviews, you would close the review. Everything requires at least one reviewer, like capital R reviewer again. If you make changes in the hotspot code, we actually require 2 reviews. So a reviewer and someone who is a committer should also review the change. Always reply to your reviewers. Thanks them for reviewing, and let them know that you consider yourself ready to push the change, so that everyone knows that the review is actually over. So, how do we do when actually pushing the changes? Well, that was like this clicker is interesting. So, if you are an author, or actually everyone needs to commit their change, of course, the commit comment should follow this template. There is the line with the bug ID that should tell the ID and the title of the bug that you're fixing. Reviewed by should contain the OpenJDK usernames of the persons who have reviewed the change. And if you're an author, you should also include the contributed by, which has your email, since you, in that case, won't have an OpenJDK username. Then export the patch and send it to your sponsor, and he will push it for you. If you're a committer, you can actually push everything yourself. So you use a tool called DevPath that is also included in the Code Tools project to set up the push path to the correct. So it uses SSH to actually push stuff. Always make sure that there are no new changes in the repository before you push your change. So do the hg-in to look for new changes. And if there is any new changes, pull them and make sure that you also use the rebase flag to rebase your changes on top of the other stuff that has come in. And this is done to avoid unnecessary merges in the code base. Make sure that you have committed and added all new files that you have changed. Make sure you don't have any outstanding merges, and push your change. So once something is pushed, we have an automatic test system that is triggered for every push that goes into the repository. This is a continuous integration test system that runs in 9 different tiers. So tier 1, the first one, is basically the same, or it's exactly the same actually, as what is run in the submit forest. So provided you have tested your change there, that one should go through. If you have been around for a while and seen old mails in this area, you might recognize the terms of hotspot nightlies and product integration tests. These are now run as part of the CI pipeline, so we don't run any specific standalone tests for these things. So tiers 3 to 5 corresponds basically to the hotspot nightlies, and tiers 6 to 8 corresponds to what we used to run as the product integration tests. There has been some shuffling around there, but basically, mainly that's. So after you push something, make sure that you are around to handle any failures. You will get email notifications if some test is failing. The email might not be extremely informative because we can't really send too much information out outside of the Oracle firewalls. But if you get a mail, contact some Oracle engineer, and they will help you figure out what went wrong. In case there is any failures, you are expected to be there to handle it more or less immediately. It affects a lot of people if there are failing tests. So don't push and run, as we used to say. Pushing on a Friday afternoon is usually a bad idea unless you want to spend your weekend looking at these test results. Pushing like the last day before you go on vacation is also a very bad idea. If there is any failures, don't expect your change to be in there when you get back if you have failed to respond to these mails. Obviously, you can have someone else monitor your test results for you. So it's not like end of the world. But OK. The JDK 14 CI pipeline executes millions of tests every day, and less than 1 per mil of these executions actually fails. If you want to look closer into what actually have failed, there are, of course, JBS labels to search for in the database. But basically, this says at least something about the quality. The JDK is, as you know, installed on more than 3 billion devices, and you don't want to be the one who breaks it. So make sure that you test your changes very well, extensively. OK, so that was more or less my last slide. There's, of course, one of these things. And there's one of those. So there's the session survey. Please fill it out. I will also be talking tomorrow in the Oracle Groundbreakers Hub at 2 p.m. So if there's anything that you want to have more clarified, I'll be there to answer any questions. And I believe we actually have time to answer questions now as well, if there is anything. Otherwise, thank you very much for listening.
What if I want to work on some of the, right? So, and I created the separate branch, right? So I have my changes. So can I push that changes and to my repo, branch, right? And then create a kind of a pull request, or how do
OK, no, so
you know when you do the development, right? So you have a you usually create the branch, right? So you push the changes, then the automated tests and all that stuff.
Yes.
When it's everything done, you can create a pull request.
Right. So